Greetings to you all. My name is Kinili Malapo. Today I'm going to teach you mechanical technology, welding. Under welding, I'm going to teach you a topic of forces. So first of all, you have to know that we have different types of forces, which are pulling force, compressive force, shearing force. And also the other thing, don't be confused. Sometimes pulling force, they call it tensile force. So now let's start. A tensile force is a force that stretches or pulls a material apart. A tensile force is a force that stretches or pulls a material apart. So I'll give you a simple example on this. Now, um, you have two groups of people who are in a competition of pulling a rope to see which group will win. So these two groups will the other group will be on the right hand side and the other group will be on the left hand side. So in between of these groups, there will be a rope. So these groups are doing what? Are pulling a rope. So when they pull that rope, pulling force is what? Is applied because they do what? They pull. They do what? They pull that rope. So first, even if maybe you have a ribbon, when you have that ribbon, you pull that ribbon on your right hand side and on your left hand side. When pulling that ribbon like this, the ribbon stretches. So a tensile force is applied. Compressive force is a force that squeezes or pushes a material together. A compressive force is a force that squeezes or pushes a material together. So for a compressive force, I'll give you an example with a string. When you push that string down, compression is applied. Or, okay, when you go to class, then you are there at the class, you sit down on the chair. When you sit down, you are applying compression. So when sitting down, compressive force is what? Is applied. Then when you stand up, there is no compression. But when you start sitting on that chair, compression is applied. A shearing force is a force that causes parts of materials that to slide past each other. A shearing force is a force that causes parts of material to slide past each other. You have two objects on a surface. And those objects are, the other one is at the bottom and the other one is at the top. The one at the top is sliding down. The one at the bottom is being pulled up. So those two objects are going past each other in what? In opposite directions. So that's a shearing force. So here are some examples that I have for you. So here is a spring that is at rest. When you push that string, compression is applied. Same as when I say when you sit on the chair, compression is applied. When you stand up on the chair, compression is released. So when you push that string, compression is applied. So compressive force is at work when you push that string. But when you release that string, compressive force is not at work. That's what you have to know. So, the other thing that you have to know. So, you have the other one. You have a bridge neck. Then you have bridge cables. These are bridge cables. Then these cables, I get they pull this surface of the bridge. They pull it like to balance it. So you have but again, you have a tensile force like here. So you have a bridge and bridge cables. So these bridge cables, they pull the surface of the bridge so that the bridge can be balanced. When they pull this thing, it is what? It is a pulling force, which is pulling force is at work. Then these cables here, they stretch from this thing to this thing. They stretch. When stretching, that's a what? That's a tensile force. So since on this bridge there is an object, that object is a truck. That truck on this bridge applies a force. When it applies a force, compression is what is applied. So compressive force is at work. When this object, this truck is like it's not here, then there is no compression because on the bridge there is no object that applies a compressive force. Do you understand me? So I think now you have understood the difference between a pulling force and a compressive force. You have to know that a pulling force, like a pull, like you can hear this pulling force. Compressive force is when you apply a force pushing. When you push a string, you apply that force. That's the things that you have to know. So now we are coming to components of components of forces. So for components of forces, I'll start with I think we have two triangle of forces and parallelogram of forces. So I'll be starting with the triangle of forces. So you have to know that this shows the direction of the magnitude. Yeah? This like this arrow here, this arrow here, it shows the direction of the magnitude. Then here, it shows that there is a tail here. Then here is the head. So this shows that the line that will be drawn from here to there, it will also go upwards. Like it will go upwards because of what? Because there is a head here which shows you how your lines must be. I guess these things must have direction. So, okay, let me just do it like this. So this will be going upwards. So since here you have your tail and your head. So the thing that you have to know about again, triangle of forces, you have to know that you have your vertical and your horizontal components. You must always know that your vertical components are your y-axis. Your horizontal components are your x-axis. So you also have a resultant, like a resultant force. So when you let me draw a bigger triangle. Okay, okay, it's fine. So now here, ne, you have your triangle. No, this is not to make sure. So so now here you okay, let me just erase this. So you have your triangle here, ne? Then this is your this is your triangle. This is your triangle here. Then since you have a triangle, okay, then this goes in this direction, ne? And also this. Yeah, and also this goes in this direction. So this one will also go that. So here is your head and here it's your tail. Ne? Then you have an angle of 90 degrees here. So you know that the side opposite this angle is your what? Your hypotenuse. Ne? Then to know your opposite and your adjacent, maybe let me say you have an angle here, angle here, angle here. Then this is your opposite and this is your adjacent. So when so there will for triangle of forces, you have to know that the formula for your uh, horizontal components is for horizontal components, ne? Okay, you have horizontal. So to get your horizontal components, you have to calculate all, like maybe if you have two triangles on a Cartesian plane, you have to calculate all the horizontal components. So your horizontal component is your x, ne? So it will be f at x, ne? F at x equals to F, the force that will be given on that triangle, F, the cos of an angle, which I will say it's 8 theta, don't mind me, F the cos of theta. So for your vertical components, you have to know that your vertical components are your y components. So Fy is equal to F, the first that you'll be given, the sine of an angle, which is theta. So for your vertical components, you have to add all your axes that, like, you have to find all of them. Then for for your vertical components is your y. That's my mistake. Please forgive me. So for your vertical components, you add all your y's. Like I showed you, this formula is the formula to find your Fy. So you add all of them, then it will give you your what? Your vertical component. For your horizontal, you calculate all of them like this using this formula, then it will give you a horizontal component. So the other thing that you have to know is the formula for finding they can say to you, find your vertical components. Then after finding your vertical components, the next question can say, find your resultant force. So to find your resultant force, you have to know the formula. The formula for your resultant force, is R equal to square root of horizontal components. I said what? Horizontal components. Horizontal components squared. You square your horizontal components. Then you add plus your what? Your vertical components all squared. That's the formula to find what? To find your resultant force. So if you want to know the direction, you have to find an angle so that you can know in which quadrant it's your what? It's your resultant force. So to find in which quadrant are your forces, like it's your like the other like a real, you will calculate your resultant force, then you get your resultant force. So after here, it's for your angle is tan theta equal to your tan theta. When you have to find the angle so that you can know uh like you have your Cartesian plane again, in which of the four parts is your resultant force, or in which direction, when you want to know the direction. So it will be tan theta equals to, in which quadrant? Yeah, in which quadrant. So your tan theta equals to your vertical components. Your vertical, I said what? Your vertical components over your what? Over your horizontal components. So you all know that when we will look for the theta, we will say theta equals to tan arc. Then in brackets, you put your vertical over horizontal components, you close the bracket. You will get the angle. Then you'll know in which quadrant. So before going to a parallelogram, I want to know you guys if you understand this, because one thing I know about this is that, okay, uh, don't forget that when you are looking for your vertical and horizontal components, I get your horizontal components are your x components. So, uh, I get vertical components are all of them combined or subtracted. So to know that you have to add or subtract, you have to look at your, agree, you will look at, let me draw it. You have a Cartesian plane here. Uh, then maybe here maybe you have 50 N. That's your force, ne? Then this goes in this direction. You don't just say because this is on the second quadrant, that means my x is wrong. You check the direction of this force, because when you check this direction, that means your y will be going where? Upwards. Then your x will be going where? To the left. That's what you must know. Then this shows the direction. So of showing the direction, this shows you have to add or subtract. Same as this side, you have this, it goes there. Then you have this one, it also goes there. Then you have this one going there. So this goes on your right. So this shows the direction. This shows which sign you must use for the f at x. It shows that you have to use the positive, this one, the negative. So this also shows which one you have to use for the what? For the y. So that you can get your horizontal and vertical components correct, you have to know the direction. You have to know whether you need to add or subtract. Because if you add instead of subtracting, when you're going to write it as a vertical component, then you don't forget that that vertical component is still going to work when you need your resultant force, and it is still going to work when you need your angle. So that means it will give your angle a wrong direction. You will never know which direction your angle will go, whether north, south, or you'll never know. So you have to be very careful with that. So maybe here you have an angle of, let me say, 30, angle of 30, angle of 30 degrees. So this side you have maybe, let me say, an angle of 20 degrees. Second, mind me. Sorry. Then here maybe you have 100. I'm just giving an example. 100, 100 what? And so this is the opposite. So this is your vertical. So you know that the formula for vertical if it is so okay, let me show you with two things now. So your formula for, let's start with the horizontal, okay? F at x. F at x. No, I'm using the wrong thing. Okay. You have to know that okay, let me say, F, let me choose another color, okay. You have to know that your F at x, is equals to your F, the cos of what? The cos of theta, an angle. So this sign will be controlled by this, whether left or right. So for this one, you know that is negative, for this one is positive. Then you calculate them. Then after calculating, maybe you can say negative this, then you say plus this. You understand me? So for the vertical, they're all positive because you can see already they're all going up. So I think we are done with the, okay. I think we are done with the triangle of forces. So now let me just give you an example for parallelogram of forces. Okay, so for your parallelogram, you have your F1, your F2, your angle theta, your angle A. So this is another maybe triangle outside. I just highlight. So for a parallelogram, you have to know that this side is equal to this side. Then this side here, it's equals to this side. So the formula for maybe in a parallelogram, they say find a resultant. So when you find a resultant force, the formula for resultant force is R. I think this one you cannot see it very well. So the formula for a resultant is R is equal to then square root, square root of your, like, maybe sorry, here is your R. Here it's your R, like here on top, not here. Yeah, here's your R. So your formula for resultant is R equals to F1 plus F2 squared, like F1 squared plus F2 squared. So it's F1, F1, then you square this F1, you say plus your F2 squared, then you say plus your 2 F1, F2 cos of angle plus 2 F1, F2, 2 like 2, then the cos of an angle. That's your theta, okay? Then we increase the square root. So that's your formula for your resultant force, ne? So the other thing you have to know is that for your angle, when you maybe look for another angle, it's going to be tan of, okay, the tan theta, tan theta is equal to, tan theta equals to F2 sine of angle A. F2, yeah, F2, the sine of an angle over F1, F2, the cos of an angle over F1 plus F2, the cos of an angle. Okay. So now I showed you the formulas. There is this other thing, like I want to highlight on this. Okay. Like you can see here, we have a triangle. So this means you have this triangle and that triangle. So let me give an example. Maybe here you have a 90 degrees. I'm just giving an example. So if you have a 90 degrees here, that means it is simple to find your resultant. And you also have your angle here. Then this will be, this here will be your opposite. So you have no stress. You can use the what? The triangle of forces what? Formula. That's simple. So for this parallelogram, you can see that this angle, like this, so it means that this angle equals to this angle. Then this angle equals to this angle. So since you have this angle, you're going to use, if maybe they didn't bring this one, you're going to use the formula for, you're going to use the law of parallelogram of forces. So I think you understood me. So okay, for the parallelogram, let me give you examples, maybe a question, like show you an example how a question can come for a parallelogram, because it is a bit tricky. So here I have an example. So here they say, let me do it like this. Then this is angle. The angle must have that thing there. And then this is also an angle. So guys, okay, let's start with the first one. This one is for a parallelogram. Then the other one is for the triangle of forces. So here they say two forces of 5n and 7n. So firstly, you know that this is your F1, first one. Then this is your F2, first two. Then bar two forces 5n and 7n act at a point of an angle of 60 between them. Find the magnitude of the resultant force. So I told you that the formula for resultant force for barking for Ndweki for parallelogram is R is equal to F1 squared F1 F1 squared plus F2, sorry, I made a big F, okay, F2 squared. Then you say plus 2, never forget this, plus 2 F1, oh no, F2, F2, the what? The cos of what? Of an angle. The cos of an angle. So your angle, sorry guys. So never forget that all of these things are all squared, ne? Never forget that. Alright, these things are all squared. So, okay, let me use a smaller yellow one. So here, I will say which is equals to, what is your F? Let me say square root here. What is your F1? Let's go back. Our F1 is what? Is 5. Then you will open your bracket here and put your 5 inside and put your... Yo, sorry guys. So you will just say, okay, we'll just, let me zoom it for you so that you can see. Okay, let me reduce it. Okay, here you'll just say like, okay, let me close here. Open bracket. Then you put your 5 inside here. Then you square your 5. Square. You say plus your what? Your F2 is what? Is 7. You square your 7. Then plus, never forget this one, 2. Then open bracket. First one is 5. Close bracket. First 2 is 7. Close bracket. Then, okay, sorry guys. Close bracket. You have to close that bracket. That's 7. Then the cos of an angle. Like we have an angle there on the statement. You have to read your statement. Your angle is what? It's 60. Okay. You have to know that angles have to be in degrees. So mind me, I made a mistake there. Sorry guys. Then your angle is 60 degrees. So never forget that all of these things are squared, because if you don't show that all of these things are squared, you'll be confused on your calculator. So our R is equal to, so you have to know that this, you have to say, but again, the square root of 5 squared plus 7 squared plus 2, 5, 7, the cos of 60. So your answer here is, let me check. Your answer is, it says square root of 9. Then 109, I mean square root of 109. You can't leave your answer like this, because what if in the next question you have to, so your answer will be R equals to, let me check, 10,44. 10,4. I just rounded it off to 2 decimal places. Don't be confused, guys. Then you don't just say 10,44. They can give you wrong. Even if the answer is correct, you have to say what? N. You have to write the SI unit. So that means you're done for this one. So let's go to the next question. This one is for a triangle of forces. The forces of 10N and 50. Ah, no, it's the same as this. Okay. For triangle of forces, and they give you one force, but I want to show you that since this is at 90 degrees, you can use that formula for okay, before going there. 90. This one is for parallelogram. I'm sorry, guys. I made a mistake by saying what I said. Okay. Here they say, okay, 15 and 10 and 10. Okay, guys. Here they say the force of 10 and newtons and 10 and 15 newtons act at a point of 90 degrees to each other. Find the magnitude and direction of the resultant force. So I am starting with the resultant force. You know your formula, R equals to F1 squared, F1 squared plus F2 squared, then plus your F plus your F plus 2. Yeah, never forget that 2 plus 2F1 F2 to your 2 so the cos of theta. So here you have your what again? You have this. So let us substitute. Okay, my F1 is what? My F1 is 10. Sorry for not naming them. Forgive me. My F1 is 10. Okay, it's 10 squared. Then plus my F2 is what? My F2 is 50. 15 squared. Then plus 2 F1, which is 10. Then F2, which is 15. Then the cos of angle. Like if they give us an angle which is 90 degrees, so you have to write it. The cos of 90, the cos of 90 degrees. So never forget this, guys. Never forget your what? Your square root. Okay, equals to here. Sorry, guys. Let me make it like this. Okay, this is your equals. So you press your calculator. Your R is equal to, okay, which is equals to 5, the square root of 13, 5, the root of what? 13. Then your final answer R is equal to 18,03. I'm rounding to two decimal places. 18, 18,03 N. Like make sure that you press your calculator correct. So now we are looking for the direction. I told you the formula for for looking for the direction, like the formula for Okay, now we are looking for the direction. Huh? Never forget to write your formula first. Your tan theta, your tan theta is equals to F2, F2, your tan theta equals to F2. Okay, my battery is low, guys. So, okay, let me increase this. Okay, your tan theta equals to F2, the sine of an angle. Sine angle, sine angle, angle, divided, which is over F1 plus F2, the cos of an angle. So your F2 is what? My F2 is, let me go back. My F2 is 15, so it's going to be 15 sine 90, sine, sine 90, sine 90 degrees over F1 is 10 plus 15 sine of 90 degrees, sine of 90. And yo, the cause. I'm sorry, guys. I don't want you to make the same mistake that I'm making here. On top is the sign, then at the bottom is the cause. 15, the cause, not the sign. 15, the cause of 90. So here is tan theta, equals to. So let me calculate this. Okay, over 15. Let me see, tan that 15, the sine of 90 over, okay, over 15, the sine of 90. Then F1 is your 10 plus what? Plus 15, the what? The cos of what? Of 90. Okay, so here it's going to be tan theta equals to tan arc. So when calculating this, guys, I got 3 over 2. So it's going to be 3 over 2. You can use a calculator if you. So your tan your theta equals to. So I got this. So I'm going to say tan arc 3 over 2, which will give me 56,31. I get I'm rounding off to 3 decimal places. 56, 56, yeah. 56,31. Never forget that this is what your degrees. So you have to write down then this is above the horizontal. So you will say above, 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 above the horizontal. Right? Above the horizontal. So guys, I think we are done with component. I think we are done with components of I think we are done with components of. Yo, Sanchik Chomuluche. Okay, I think we are done. Yeah. Okay, yeah. I think we are done with components of what can you do? With components of forces. Okay. So now we are coming to our last thing. So okay, guys. Before going to another topic, you have to know that the importance of resolving forces. It helps you break complex into manageable parts, making it easier to apply physical laws and solve problems accurately. That's what we were doing here. So now let's go to another topic, which not topic, I mean, to the last title that I will teach you. Let me see that. So moments. Mo moments, ne? Am I writing it right? I know you can't see it. I can tell that no. So now we will be talking about moments. Moments, ne? So you have to know that moments is equal to force. Moments is equals to force multiply by perpendicular what? Multiply by perpendicular multiply by perpendicular distance multiply by perpendicular distance from the pivot from the pivot. What is moment? Moment is force multiplied by distance is force multiplied by distance perpendicular what? Perpendicular pivot. So let me draw a diagram for you so that you can understand what I'm talking about. So let me maybe make a triangle or something, okay? So here you have your first side going that side, then you have your other side from here going and no mistake for then you have another side here going that side also. Okay, they're going that side. Then after you have a side like here, this side, you have another side here going that side. My diagram. Okay, my diagram is not straight. Okay. So let me make it straight so that not like straight. Let me just make it. You understand me? Mm. I think this thing must be like this. This, okay, okay. Then no, I think it must be like this. Then this side it must be reduced like this. Okay. So okay, let me put this one nicely. Okay, so you have your pivot here. Like you have your pivot here. Here's your pivot. Ne? So you have your angle of 90 degrees here. Akere, you can see that this formula says moment is equals to force multiplied by perpendicular distance from the pivot. Perpendicular distance from the pivot. So this side is your what? Is your distance. Never forget that. Then this side is your force. This is your force. You have to understand this diagram. You have to understand this formula. Moment equals to what? Pivot equals to force times perpendicular pivot. So I have shown you that this is your pivot. Let me circle it. Moment equals to your force multiplied by perpendicular distance from the pivot. From the pivot is from here. perpendicular distance from the pivot. So this side is your distance. You have to know that. So to know your direction, you will see by your force. So you can see that this thing is going like this. So which is what? When it goes like that, which is anti-clockwise, anti-clockwise. Then if your force was going like this, so that means it was going to be like this, which was going to be what? Clockwise. That things you have to know them. So, okay, I explained the diagram to you. Okay. So after this, let me try and make questions. So now there is a question. They say a force of 20 N is applied to a distance of 0.5 from a pivot. This must be of 0.5 from a pivot. Ne? Okay, from a pivot. Then they say calculate the moment produced. Since you know the formula of moment, okay, moment as m equals to m equals to F, which is the force, multiplied by perpendicular what? Distance from the what? From the pivot. So your force is 20 multiplied by, I get force is measured in N. So, okay, we'll chalk that in 0.5. So you have to say 20 multiplied by 0.5, which is 10. So your moment produced M equals to M is equals to 10 N M. Do you know why the SI units for moment is Nm? Because is the force which is the SI unit is N multiplied by the distance which is M. So Nm. Do you understand me? Okay, so we are done with moments. Let's do stress. So we are now going to talk about stress. At the beginning of uh, this channel, this video, I told you that we have three different types of stress, of forces, which is compressive force, shearing force, and what again? And tensile force. So those applies, they also applies to stress. We have a tensile stress, compressive stress, and a shearing stress. So you define them the same. You have to know that. So stress, the intro is like the formula is stress equals to force over area. So your intro is like this for stress, and equals to force over area. So since I explained those things at the beginning, that means you can understand the ones for forces. So to force over, or stress equals to force over area. So the area, the Fundeki will be, the force is measured in F, then is measured in, the area is meter squared. You all know that. So that means if they say calculate stress, if they say maybe they have a force of water at F, maybe 50 N, and an area of 0.3 meters squared, calculate the stress. So you'll say that force over area. Then your SI units can be N over M squared or PA, Pascal. So now I'm coming to, in stress, we have a square bar. We have a stress in a square bar. So a stress in a square bar. So you know the formula for a square bar. A square bar is equals to like Z times side. So a stress, let me give you an example. A stress bar is equals to side times a square bar. Okay. Since I said stress equals to force over area, so now I have an example. Stress in a square bar with a side of 10 millimeters is loaded with a load of 4,000 and find the stress. So you know that stress equals to force over area. So you have to find the area first because already they gave you the force. So I think now, okay, let me use this one. Okay. So now your area of the square bar is area equals to side times side over 10 equals to side times side. The side is 10, so you could say 10 times 10. 10 millimeters times 10 millimeters. So your area equals to, yeah, equals to, so let me check my battery. Okay, your area equals to 10 times 10, right? Your area equals to 100 millimeters. So you have to know that this must be measured in meters. 100. So from millimeters to meters, we divide by 1,000. Therefore, your area is equals to, no, here is squared, ne? So you have to say divide by 1,000. Your area, no, we're not dividing by 1,000. We will say 100 times 10 to the power negative 6. I'm very sorry about 100 this times. I get from millimeters to negative 6. So that means we divide by 1 billion. Then your stress equal to your force, which is 4,000 for 1, 2, 3 divided by 10, 100, I mean, times 10 to the power negative 6. Nep. So since it's like this, we are going to see 4,000 over again 100 times 10 to the power negative 6. Yeah. 100 times 10 to the power negative 6. This is 1, 2, 3, 2, 4. So it's 100 divided by 1, 2, 0, 1, 400 divided by 1, 2 by 10, 10, 4, 0, 0, 0, 0,00245. So here it's your A. So that means 4,000 over okay, over 0,01 over 0,001. Okay, guys, I made a mistake here. So this here is going to be, okay, 4,000, which is going to be 4,000 from milli, like you have to know that from millimeters to, so 4,000 over, okay, guys, so let's not convert it and leave it like this. So we'll say 4,000 over, your area is just 100. Then here is 4,000 over 100. So your answer will be 40 MPa. MPa. I made a mistake there when I said pascals. It's MPa. So your stress, sorry, your stress, your stress, your stress equals to 40. Because when you do, you're still going to have 40 M MPa. Stress is measured in MPa, guys. This one is for MPa. So now we are going to the second one. A round bar. Round bar. Firstly, you have to know that the area for like circle, that's area equals to pi r squared. Pi r squared over distance. Over distance. Which is equals to, so our pi, you just say pi, like it is there on the calculator. Then our r is the distance. Since they gave us the distance here, they say 20. So guys, sorry, my mistake. From millimeters to meters, we divide by 100. So it's 20 divided by 100. We divide by 1,000. From millimeters to meters, we divide by 1,000. So then 0, 0.02 all squared pi r squared over distance. No, not distance, over the diameter. I didn't read the statement first. I get about a round bar carries a what was calculate the root. Carries a diameter of 20, mama. So it will be pi over, here is not into, it's r over 4. The formula is pi r squared over 4. So it will be over 4. Then to find the area, your area will be equals to, area is equals to, so you say over your pi, you say where's your pi? Your pi 0.02 squared over 4. Then you get your answer. You get your answer, which is pi r squared over 4. Let me see. 144. Then your answer is 3,1446. That's your answer. Okay. 3,14. Ah, 1,446 times. Don't worry, guys. I'm checking on my calculator. 10 to the power negative 10 to the power negative 4. Then after you look for stress equals to, then your stress is equals to force over area. They give you a force, I'm very sure about that. Your force is 5,000. Then stress equals to 5,000 over 3,144. 3,146 times 10 to the power negative 4. 10 to the power negative what? 4. Okay, so 5,000, eh? So your answer will be 15 comma times 10 to the power 6. So your answer will be 15,9. You multiply that 15,9 times 10 to the power 6. So 5,000 over 3,446 times 10 to the power negative 4. Then the answer that you got, you multiply by 10 to the power. Then your answer is 15,9. Stress equals to 15,9. Okay, guys, so I'm done for today, and thank you, everybody. I hope you understood. If maybe you didn't understand something, I missed something, please share. Or if you have a question, please share on the comment section. Then I can make another video explaining to you, or I can explain to you. Thank you very much, guys.